The students will continue the problems in residues. You see that 8th problem. Find the residue of z cube by z square minus 1 at z equal to infinity. At z equal to infinity, I have given two formula. So use first formula here, since you have only one factor here. If you have only one factor, use the first formula. What is that residue at z equal to infinity formula? Sorry. Minus coefficient of 1 by z in the expansion of f of z. In the expansion of f of z. Okay. If you have only one factor in the denominator, use this formula. Use the first formula, residue at z equal to infinity. If you have more than one factor in the denominator, use the second formula. What is second formula? Residue at z equal to infinity is limit z tends to infinity of minus z into f of z. So in the denominator, if you have only one factor, use this formula. In the denominator, if you have more than one factor, use the second formula. Now see here. So I am going to take z square outside. So 1 minus 1 by z square. So z cube by z square is what is z? You take this factor to numerator. Whole power minus 1. Now what is binomial series? 1 minus x whole power minus 1. Already we discussed in Taylor series on Lorentz series. 1 plus x square plus x cube, etc. So using that 1 plus x is 1 by z square. 1 by z square whole square is what? Z power 4, etc. And multiply by z. Here 1 z get cancelled. Here 1 z get cancelled, z cube plus. Now we expanded this function. Now write the formula once. Residue at z equal to infinity is minus coefficient of 1 by z. You have to take only coefficient of 1 by z. In this series, where is 1 by z? You check. This is 1 by z. What is coefficient of 1 by z? 1. That's all. Let's see the next problem. Find the residue of z square by z minus 1 z minus 2 z minus 3 at z equal to infinity. Now see, in the denominator, if you have more than one factor, here three factors are there. If you have more than one factor, use this formula for residue at z equal to infinity. Okay. So let f of z equal to, you write this function. Now straight away you can apply the formula. Residue at z equal to infinity is limit z tends to infinity of minus z into f of z. Minus z into f of z is z square by z minus 1 is z minus 2 is z minus 3. Or you can take this minus outside. This is z into z square is z cube. I am going to take z outside. In the denominator, I am going to take z outside in each and every factor. Okay. When you take z outside here, 1 minus 1 by z. For the second factor, if you take z outside, 1 minus 2 by z. For the third factor, if you take z outside, 1 minus 3 by z. Since we want to apply the limit z tends to infinity, you have to write the factor in terms of 1 by z. Then only you can apply the limit. Okay. So that's why we are writing like this. Now see here, this z cube get cancelled on numerator and denominator. Z cube get cancelled on numerator and denominator. I am not writing that. Now you can apply the limit. 1 by infinity 0, 2 by infinity 0, 3 by infinity 0. This 1 into 1 into 1 is 1. So 1 by 1 is 1. That's all. So this completes a problem in residues. So in the next video we can see the next topic.